Hello, good day viewers. I would like to show you 4 different ways to integrate this function x divided by x squared minus 4. But in this tutorial, I'm only going to show you 3 different ways. Alright, let's start with the first way. The first method is by the use of partial fractions. So by applying partial fraction, let me take this function and transform it into partial fractions. We have x divided by x squared minus 4. This can be splitted into x divided by x minus 2 multiplied by x plus 2, right? Because if you expand this, you're going to get this back. Then in partial fractions, since we have 2 factors here, we are going to have 2 fractions. A constant divided by the first factor, x minus 2, plus another constant b divided by x plus 2. So all we have to do is to find the values of a and b. And we can find a and b by using cover up method. First of all, we have to think of a number that can make this denominator to be equal to 0. And the only value of x that can make that to be equal to 0 is 2. And we are going to substitute the 2 into the other factor. We have 2 plus 2, which is equal to 4, right? Then we substitute that 2 to the top. When you plug in 2 here, you have 2. So we have 2 divided by 4. Therefore, our a is 2 divided by 4. This is equal to 2 divided by 4 divided by x minus 2. Then we'll move to the other one. How can we make this 0? By substituting the value of x to be equal to negative 2. And we are going to plug it in here. We have negative 2 is negative 4. And if you plug in negative 2 here, you have negative 2. So we have negative 2 divided by negative 4. So plus negative 2 divided by negative 4 divided by x plus 2. So this is what we need to simplify. If you simplify this, you have 1 over 2. This is also 1 over 2. So you have 1 over 2 as a factor. Then inside you have 1 divided by x minus 2 plus 1 divided by x plus 2. And hence this is the partial fractions of that compound fraction, which is this one. So instead of integrating this function, we can simply integrate the partial fractions. So we are going to integrate this one, but since this is constant, we can bring it out. So this is equal to 1 divided by 2, the integral of 1 divided by x minus 2, then plus 1 divided by x plus 2 dx. And remember, if you differentiate this, you are going to obtain 1, likewise this one. And whenever you have this situation, the integral of that function is just the natural log of the absolute value of the denominator. And therefore, we have 1 divided by 2 multiplied by natural log of the absolute value of x minus 2 plus natural log of the absolute value of x plus 2. Then by applying one of the laws of logarithm, since we have addition, we can multiply the argument and take 1 log. So this is 1 divided by 2 multiplied by the natural log of the absolute value of, if you take this and you multiply by this, that is just difference of 2 squares, right? The first time squared, that is x squared. Then minus the second time squared, 2 squared is 4. Then plus the constant of integration, and we are done. Alright, let me show you the second method, that is by use substitution. So by use substitution, I would like to let x squared minus 4, which is our denominator, to be equal to u. Let's differentiate both sides. If you differentiate x squared, you have 2x. You differentiate constant, you have 0. So we have dx equal to du, right? But just observe to the top, we have x dx. So how can we have x dx here? By dividing both sides by 2. So if you divide both sides by 2, you have x dx equal to 1 over 2 du. So now let us back substitute. Instead of x dx, we have 1 over 2 du. So the integral of 1 over 2 du, then divide by the bottom, which I have used u to substitute it, right? So we can simply rearrange this as 1 over 2 outside, which is constant, multiplied by the integral of 1 over u du. You should know that the integral of 1 over u is equal to natural log of the absolute value of u. 1 over 2 natural log of the absolute value of u, then plus the constant of integration. But what is u? U is nothing but x squared minus 4. So this is 1 over 2 natural log of the absolute value of x squared minus 4, then plus the constant of integration. This is the second method. And the last method is by using shortcut. So method number 3, we would like to use shortcut. Just observe, if you differentiate the denominator, you're going to obtain 2x. But the numerator is just x. But you should remember that whenever you differentiate the denominator and you realize it is equal to the numerator, then the integral of that function is always equal to the natural log of the absolute value of the denominator. But in this case, we don't have the derivative of the denominator to be equal to the numerator. But we can compensate. We can simply multiply this by 2. Because if you differentiate this, you have 2x. So we have 2x. But we have entirely changed the function. So to compensate, we have to multiply by 1 over 2. Now 1 over 2 times 2 is 1. So it's like we have not done anything yet. So this is equal to 1 over 2 multiplied by the natural log of the absolute value of the denominator, x squared minus 4, plus the constant of integration. As simple as that. So tomorrow I'm going to show you how to use trigonometric substitution to solve the same problem. Thank you for watching. Do have a nice day.